Okay, topic 6 is exponential and logarithmic functions. We're going to do a few small videos and see if that doesn't help you guys throughout this topic. Remember, this topic is shorter before the exam 3. So, exponential and logarithmic functions are inverses of each other. So we kind of need to talk about what an inverse function is. An inverse function is a function that when we go one way, we can use something to go backwards, back to the original. Not all functions have inverse functions, and sometimes only when we restrict the function. So first we're going to identify some one-to-one functions and determine whether two functions are inverses. And then we'll find the inverse of a particular function as we go along. So a one-to-one function. A function is one-to-one if for every a and b in the domain, so every a and b in the domain, this would be your x values, any values you plug in for x of a function where they're not equal to each other, so a doesn't equal b, then the outcomes do not equal the same number. This means for each x I get a very unique y. It doesn't mean I can have two x's go in and give me a y. Now, if you think about quadratic functions, if we have a regular quadratic, just an x squared, and I plug in -1, I get out 1. But if I plug in 1, I also get out 1. Those two values, those two x values, are not equal to each other. -1 doesn't equal 1. When I plug them in, I still get the same result. So they are not one-to-one. This is the same as saying if the outputs are different, if the y values are different, then my inputs must be different. So we can actually just look at the coordinate points to determine if a function is one-to-one. Here we have a set of points. If we look at this, we have 1.12, 1 comma 2. That's x is at 2, and comma 1, 1 is the y value. So my x is 2, my y is 1. Here my x is 4, my y is 2. My x is 7, my y is 3. And here I have that my x is -2, and I get out 1. So the question is this one-to-one? Well, right here I have this 2 and this -2 both give me exactly the same output. They both give me 1. So if I have two x's that give me the same output, then it is not one-to-one. Not one-to-one. Now, that was with the actual, have to keep that in mind. That was actually with the recorder. So the 1 here means this is not one-to-one. Now here we have 3 and 0. So x is 3, y is 0, x is 2, y is 4, x is 6, y is 2, x is 1, y is -1. At no point here do I overlap. I don't have the same outputs, and I have individually different inputs. So this one is 1, 2, 1. So we're really looking at when you have two of the same x's or two of the same y's. So in C, I have 1 and 1. X is 1, y is 1. X is 5, y is 2. X is 1, y is 3. So this is a problem. Right away I can go, okay, this one and this one give me two different outputs. And then I have x is -3 and y is -1. Here, having an x two different x's, or two of the same x's, give me two different outputs. So this with this means this isn't even a function. Not like this one is not 1 to 1. This isn't even a function. So I have two different, in A, I have two different x's giving me the same output. That can still be a function. That would pass the vertical line test. Here, I have two lines on the same vertical point at x is 1. That can't be a function. So that isn't even a function. We go to the next one. 4, x is 4, y is 3. X is 3, y is 2. X is negative 4, y is negative 3. Again, we're all good. X is negative 3, y is negative 2. Again, no overlap. X is 0, y is 0. No overlap. This is 1 to 1. Here we have 2 for x and 1 for y, 3 for x and 4 for y, 1 for x and 3 for y, negative 3, x, negative 2, 0, 0, again, no overlap yet, negative 2 and 2. Now be careful, these aren't overlapping. This is negative 2, this is positive 2, positive 2, negative 2, no overlap. And then for the outputs, there's no overlap either, because this is 2 and this is negative 2. So just be careful when you're watching these and doing these. 5 and negative 1. 5 doesn't match any of my x's. Negative 1 doesn't match any of my y's. This is 1, 2, 1. So just looking at our data points, we can tell a lot about whether or not this function is 1 to 1. Another way to look at these is if we get, we were talking here about this won't pass the vertical line test. Going down, this wouldn't pass it. If these are 1 to 1, like here, this will pass the vertical line test, but it wouldn't pass a horizontal line test because it's not 1 to 1. This one would pass both a vertical line test and a horizontal line test. Here I'm drawing these and they look like asymptotes. I'm just drawing an invisible line. Just like the asymptotes really don't exist on our graph, neither do these tests, like our vertical line test or our horizontal line test. If they are 1 to 1, they pass both. This won't pass this one. That'll pass both. This won't even pass this one, so we don't even make the next one. And then both of these others will pass both. All right, so that's the first little video, and I'll probably do a bunch more as we go along.